Okay, today we're talking about secant and cosecant. Recall that cosine can be rewritten as 1 over secant, and sine can be rewritten as 1 over cosecant, or vice versa. Okay, so just remember that these are reciprocal functions. If I have a sine value that's equal to 0, then the cosecant is going to be undefined. And then there will be an asymptote like we saw with tangent and cotangent. Likewise, when cosine is equal to 0, the secant is undefined, and there will be an asymptote on that graph. When it comes to graphing secant and cosecant, we're going to actually graph the reciprocal functions of cosine and sine, and then we'll add the secant portion to that. So recall that secant of x is the reciprocal of that is cosine of x. So cosine, we start at a max, we go to a 0, then we go to a min, then we go to a 0, then we go to a max. And we can repeat that, follow that pattern on the other side. All right, so here's our cosine function. I'm just going to kind of lightly draw that. All right, everywhere there is a 0, and a 0 is one of those values that crosses the midline. So right here, there is an asymptote. So every time this function crosses the midline, there is an asymptote. Okay? And for every minimum, there's going to be this parabola looking portion. And it does go up or down forever like a parabola would. So mins, you go to a minimum and you draw a bowl or a parabola that goes down, and you go to a maximum and you're going to draw that portion that goes up. And yes, it does actually touch at that point. Okay, so for secant, this is the graph of secant of x. It's these little bowl shapes that go down forever into negative infinity and up to positive infinity. The domain will be all reals except where those asymptotes are. So my first asymptote is actually at pi over 2. And how long does it take to get to the next asymptote? Well, that is pi. So we would say pi over 2 plus n pi, where n is an element of the integers. The range, how low does it go? Well, it goes all the way down to negative infinity, and then it kind of goes up to the minimum of -1 with a bracket, and then after that it goes from 1 to positive infinity. And we combine those with what's called a union. This giant wide U represents a union. We're uniting those values. The period of secant is going to be the period of whatever cosine was, which is 2 pi, and that's its natural period. Okay, so let's look at this graph. To graph y equals 1/2 secant x plus 1, I'm going to graph y equals 1/2 cosine of x plus 1. So the plus 1 tells me that I have a midline right here. 1/2 is going to be the amplitude, so cosine here starts at a max, and I'm just going to go up half. And the period is going to be 2 pi, so every quarter period I'm going to have a critical point, which is at pi over 2. So I can go ahead and kind of pre-mark all of my pi over 2's on my midline. And so then I follow cosine. And then I've got a 0, a minimum, a 0, a max, and then I reverse. 0, a minimum, a 0, and a max. And again, I can kind of lightly pencil in, or I don't have to pencil in. I just like to look at it. Everywhere this function crosses the midline, there is an asymptote. Okay, and at every minimum, I'll have a secant bowl that goes down. And at every maximum, I'll have a secant bowl that goes up. And that is the secant graph. All right, here's another one. Y equals negative secant of x minus pi. I'm going to graph y equals negative cosine of x minus pi. All right, so that's a negative cosine, meaning it's going to start at its minimum, and it has a phase shift of positive pi. The period here is 2 pi. Important values will be every quarter period, and there is no vertical shift. The amplitude here of cosine would be 1. So I'm going to start at pi, so that's pi over 2, and that's pi, and I'm going to start at the minimum of negative 1. So here's 1 that represents, here's negative 1. Okay, and then of course every quarter period. So I can go ahead and pre-mark, since the midline is the x-axis, I can pre-mark those. So I'm going to have a max, and then I go 0, max, a 0, a min, a 0, a max. Okay, so there's my function. Again, every 0 is an asymptote. Okay, and then at a minimum has a minimum bowl, maximum has a max secant bowl, minimum. And there is the graph. Okay, next is the secant. So we did secant, now we're going to do cosecant. And cosecant is the reciprocal of sine. So I want to graph for the parent function of cosecant, I'm going to graph the parent function of sine, which starts on the y-axis at the midline here. Okay, then it goes to a max, then it goes to 0, then it goes to a min, and then back to 0. And then of course I would repeat that Okay, and so here's my sine function. Again, it's very light. You can make it dark if you want. It's really just so that we can get an idea of where our asymptotes are and where our mins and maxes. So, as before, every time it crosses the midline, we have an asymptote. Okay, and at every minimum, I do a secant bowl below. Every max, I do a secant bowl above. And I'm really just sketching. All right, the domain here will be all reals except, so my first asymptote is at 0, and it takes pi to get to the next one. So we're just going to put n pi such that n is an element of the integers. The range would be from negative infinity to negative 1 with the union of, go to my max, 1 to infinity. And the period is 2 pi. Okay, y equals 2 cosecant x. I'm going to graph y equals 2 sine of x. 2 is going to be my amplitude, no reflection. The period is 2 pi, and all important values are at a quarter period of pi over 2. There is no phase shift. There is no vertical shift. All right, so sine always starts on the midline at 0, 0, unless there's a phase shift. So I go to pi over 2, and I'm actually going to go up to 2 since my amplitude for sine is 2. Then I go back to 0, then I go down to 2, and then I go back to 0. Then I can reverse that pattern. Lightly sketch in sine, and where there is a 0, I have an asymptote. Okay, then all the minimums get a lower secant bowl, all the maximums get an upper secant bowl. Okay, the next one, y equals negative cosecant of 2x minus 1. So I'm going to graph y equals negative sine of 2x minus 1. This right here is the frequency. So the period will actually be pi. So my quarter period will be pi over 4. I also have a vertical shift down 1. So here's my midline. And then it's a reflected sign. So I'll still start on the midline, but I'll go down to a minimum. And I'm going to go every pi over 4. So if this is pi over 2, then halfway between is pi over 4. So every 1.5 squares is pi over 4. And then I can go backwards. Okay, so I start at 0, 0, no, just kidding, 0, negative 1, and then I go pi over 4, and I go down to 1, down 1. I go pi over 4, and I'm back to 0. Pi over 4, up 1. Pi over 4, back to 0. Pi over 4, down 1. Pi over 4, back to 0. Okay, so this is going to be up, 0, down, 0, up, 0, down, 0. And so here's my sine function. Okay, so everywhere it crosses the x-axis, there is an asymptote. Okay, so find those zeros, and those are your asymptotes. I'm just going to do straight lines. Okay, our first asymptote's at 0. Our second one here is at pi. So again, if I were to write a domain, that's how I would use that. No, I'm just kidding. That's pi over 2. Okay, so maxes, they get secant bowls up. Mins get secant bowls down. Maxes up, mins down. Maxes up, mins down. Okay, got time for one more. Y equals, this would be sine of x minus, just kidding, plus pi over 2. So that means my phase shift is negative pi over 2. So that would mean here's where it's going to phase shift at negative pi over 2. There's no vertical, so this is also the midline. It's a positive sign, so we start on the midline. And then our period is going to be 2 pi. So at every quarter period, we have a critical point. So this would be a max of 1, because that's the amplitude. Then we back to 0. Then we're down to negative 1, back to 0. Okay, and then go the reverse. So it actually kind of looks like a cosine function, but they are cofunctions. All right, so everywhere it crosses the midline is an asymptote. And at minimums, they get a lower secant bowl. Maximums get an upper. And there you have it, graphing secant and cosecant.